This is Math 1200, Trigonometry, Module 10. Systems of linear equations and parabolas. This is chapters 9.1 and 10.1 in your book. Module 10 Opener. Alright, so this is your last module. You've made it. Congratulations. This one is not very long and it's pretty straightforward. So let's get to it. In the last module, we're going to take a look at the systems of equations. The solutions of a system have to solve every equation in that system. So we're going to be looking at lots of equations and finding one solution for every equation in that system. There are many real-world applications that you're going to take a look at, mainly in your homework examples. And finally, at the end of the section here, we're going to take a closer look at parabolas and some of their applications, just some different terminology for parabolas. One of the things I want you to focus on is that there are many ways of solving systems of equations, and you should be comfortable with all the different ways. But it's okay if you have one method that you like the best. Right? If the question says solve using this method, but you'd rather do it in a different way, then that's fine. Right? Objective 1: Systems of linear equations. In a system of equations, any solution must be true for every equation in the system. When the system is linear, a solution is represented by the intersection of the graphs of the lines. Okay? So in other words, if you have a graph and you have the equation of one line and then the equation of another line, then the solution to that system is their intersection. That point, it's an x and a y value, wherever they intersect. Notice that there are times when two lines don't intersect. That's when they are completely parallel. If the lines are completely parallel, then there are no intersection points, so there are no solutions. No solutions. Okay. If the lines are the same line, for example, if this is the equation of one line, and then you have another line that completely overlaps it, then obviously they intersect everywhere. So the solution is usually represented as all the real numbers from negative infinity to infinity. Okay. Or we say infinite solutions. But usually there's only one point of intersection, and that's what we're going to look for. One usual method is called the substitution method, in which you'll solve for one variable in one equation, and then substitute it into the other equation. Let's take a look at a problem. So for example here, it's your choice what variable you want to solve for. To me, it seems easier to solve for y here. So I'm going to solve for y. That's easy for me because I can just add x to both sides. That would give me y is equal to negative 1 plus x. Now that I know what y equals, I can take it and substitute this into the second equation. Instead of writing y plus x, I'm going to write something plus x is equal to 5. And what is my y? Y is now negative 1 plus x. So that's what I'm going to write in here. Negative 1 plus x. Because y is equal to that. I'm going to combine terms. Negative 1 x plus x is 2 x's. And I'm going to solve for x. Add 1 to both sides. And divide by 2. I found the x value where the lines are intersecting. To find the y value, I'm going to go back and put it into my y equation. Y is equal to negative 1 plus x, which is 3. So y has to equal 2. And that's my point of intersection. 3, 2. There's another method called the elimination method. In this method, we're going to line up the corresponding variables. They have to be lined up and multiply by an appropriate number to cancel out a chosen variable. Multiply so that you can cancel. For example, here, the variables are lined up. The x's, the y's, and the numbers are lined up. They're all on top of each other. Notice that if I multiply this equation by 3, the second equation, all of it by the way, by 3, then that would give me negative 3x, which would cancel with this positive 3x. So that's what I want to look for, and that's what I'm going to do. Multiplying that equation by 3 gives me negative 3x plus 3y is equal to 9. Negative 3x plus 3y is equal to 9. And the top equation stays the same. 3x plus 2y is equal to 11. Now if I add straight down, these cancel. I'm left with 0. That's 5y. 2y plus 3y is 5y. 11 plus 9 is 20. So I get that y is equal to 4 when I divide by 5. Now that I know what y equals, I can go ahead and plug that into either one of these equations. I think it's easier to do it for this second one, so that's what I'm going to do. Negative x plus y, which is 4 now, is equal to 3. So that gives me that negative x subtracting 4 gives me negative 1. So dividing by negative 1 gives me x is equal to 1. And that's my solution. 1, 4. Parabolas. Recall the graph of a vertical parabola with vertex h, k is given by y is equal to a, x minus h squared plus k. Notice that the h is an x value, so it goes with the x. The k is a y value, so it goes not with x, right, outside. It's whatever is added to the entire a x minus h squared. A graph of a horizontal parabola, in other words, one that opens either to the left like this or to the right like that, versus a vertical parabola, opens up or opens down, is given by x is equal to a times y minus k squared plus k. Notice that the k, which is a y value, is now with the y here, y minus k squared. Notice, however, that the graph of a horizontal parabola does not represent the function. It fails the vertical line test. Notice that any vertical line will cross it more than once. So this is not a function, but we can still look at it in not a function. We can still look at it and study some of its properties. What is the domain and range of x plus 3 is equal to y minus 2 squared? Notice it's in the form of a horizontal parabola. Right. Since this is a positive 1 here, 1 times that, we should know that it opens to the right. Right. If there was a negative value there, like negative 2 times y minus 2 squared, it would open to the left. So writing this in the vertex form, it would be x is equal to y minus 2 squared. Subtracting this 3 to the other side would be minus 3. And that should tell you that the vertex is, right, what does it say? It's h, which is negative 3, and then k, this is minus k, so minus a 2. That tells you that if you regraph this, the vertex is at 1, 2, 3, 1, 2, right there, and it opens to the right. So the domain is the x value, so starting at negative 3 all the way to infinity. and the range is negative infinity to infinity, because this thing keeps getting lower and lower and lower. This thing keeps getting higher and higher and higher. So it's negative infinity to infinity. And we can include this -3. The geometric interpretation of a parabola. A parabola is a set of points the same distance from a fixed point, we're going to call a focus point, and a fixed line called the directrix. What that means is that, once you see this, it won't be that many, that if I have some point right here, I'm going to call this a focus, one single point, and a line down here, which we usually call the directrix. Parabola is just this is not exactly that good of a drawing. The parabola is the line like this that is the same distance from the focus. So this distance has to be the same as this distance for any points. This point right here has a distance to that focus, and it should be the same as the distance to the directrix. This point here has a distance to the focus. It should be the same to the directrix. My drawing is not exactly perfect, but that's what a parabola is defined to be. A line or a curve where the distance from the focus to the directrix is always the same. So we can even do it for a horizontal parabola. If that's our directrix and that's our focus, the parabola would open towards the focus, and the distance from any point, for example here, to the focus should be the same as the point to the line. Those lines should be the same length. A parabola in the form x squared is equal to 4 times p times y has a focus of 0p, and the directrix y is equal to -p. For example, the parabola x squared is equal to 8y can be written as x squared is equal to 4 times 2 times y. That tells us that our p is 2. In other words, the focus is 0, 2, and the directrix is y is equal to -2. If we were to draw that, 0 for x, y is 2, 1, 2. There's our point. Y is equal to -2, 1, 2. There's our line. Y is equal to -2. And our parabola opens towards the focus. Okay. Finally, a parabola with a vertex h, k is of the form x minus h squared equal to 4 times p y minus k. And here the focus is now the distance, absolute value of p from the vertex. Let's look at what that means in an example. So if I were to ask you to write the equation for a parabola, in other words, write something like this, with a vertex 1, 3 and focus -1, 3. Right? First, we should start off by noticing that this is the equation of a parabola that goes up or maybe down depending on the value in the front. So let's make sure we even have something like that. I'm going to draw a graph. I'm going to put the vertex 1, 3. 1, 2, 3. Focus is -1, 3. -1, 3. So if this is the vertex and that's a focus, the parabola has to open to the left like that. Something like that. That means that this is not the general equation, we're actually looking for something like y minus k squared is equal to 4 times p x minus h. Okay? And now we can plug in our values. Y minus k is our 3. The y values go with the y values. 4 times, let's leave the focus alone for now, x minus h, which is 1. And the focus here, when it says the focus is the distance of absolute v from the vertex, that means that the distance here from the focus to the vertex is, if this is -1 and that's +1, is a distance of 2. So this should be, and because it opens to the left, it should be -2. Right? Because it opens to the left. If the graph would have looked like this, we would have taken that to be +2, but it doesn't. So our equation is y minus 3 squared is equal to -8x minus 1, which matches up with everything that we know. The -8 tells us that the equation opens, that the parabola opens to the left. So try this one on your own. Solve the system of equations using whichever method you want to. Right? If you're going to use the substitution method, solve for y or x and substitute it into the second equation. If you're going to use the elimination method, maybe multiply the top equation by something. Maybe multiply it by what would give you the same value? -3, right? Or you can you can solve this using the graphing method. Graph x plus y is equal to 2. Graph 3x plus 3y is equal to 6. Right? Try either one of those methods, and you'll see that when you do that, that these equations are actually equations of the same line. So the solutions are infinite. It's not a number of solutions. Infinite solutions. They're actually the same graphs of the equations. Okay.